In a curve, another phenomenon occurs. Besides conserving its trajectory, our bottle of water has conserved its speed and has come to a stop further away. This is caused by kinetic energy, better known as momentum. A body in motion accumulates a quantity of energy called kinetic energy. For example, if you cease to transmit engine power to the wheels by setting the gear shift lever in neutral, the vehicle will continue its trajectory. It will slow down gradually because of resistance from air and the rubbing of moving parts of the vehicle. Kinetic energy is proportional to the weight of the vehicle. Let's compare these three vehicles. The medium-sized car is approximately 2 times heavier than the small subcompact, while the minivan is approximately 3 times heavier than the subcompact. Let us assume that our 3 vehicles are traveling at the same speed. Compared to our small subcompact, the medium-sized car, which weighs approximately twice as much, develops twice as much kinetic energy. The minivan, which weighs approximately 3 times as much as the subcompact, develops 3 times as much kinetic energy. Therefore, at equal speeds, if we double the weight of the vehicle, we also double the kinetic energy. As well, if we triple the weight of the vehicle, we triple the kinetic energy. Not too complicated, is it? Now, let us move on to the second aspect of the question, kinetic energy in relation to speed. This cannot be calculated in the same way as kinetic energy in relation to weight. This energy increases in proportion to the square of the speed increase of the vehicle. Let's compare 3 vehicles of the same weight to illustrate this fact. The vehicle above is traveling at 20 kilometers an hour, developing a percentage X of kinetic energy, represented here by 2 lines. The vehicle that is traveling twice as fast as the one above will develop 4 times more kinetic energy, represented by 8 lines. The vehicle traveling 3 times as fast develops 9 times more kinetic energy, represented by 18 lines. All that to say that speed plays a big role in increasing kinetic energy. To better understand, let's compare 2 different vehicles. Let's take our subcompact traveling at 20 kilometers an hour and compare it to the minivan, which is 3 times heavier, traveling at the same speed. At equal speeds, the minivan accumulates a kinetic energy that is 3 times higher than the first because of its weight. However, if the subcompact triples its speed, it will develop more kinetic energy than the minivan, which maintains its speed at 20 kilometers an hour. Let's calculate. The subcompact develops a percentage X of kinetic energy, represented by 2 lines. It triples its speed and develops 9 times more kinetic energy, represented by 18 lines.
Fourth point to remember, the increase of speed has more important consequences than the increase of weight, in case of impact, for example.
For a vehicle to come to a stop, its kinetic energy must be converted into calorific energy by friction, such as braking.